So welcome to this latest video 162 Maths, and in this video we'll be going over some GCSE Maths higher probability with the focus of looking at some extremely difficult questions taken from past exam papers. Now as always, I'll include a copy of the questions in the description below for you to download and have an attempt at before watching through these videos. We go through the answers so you can test your prior knowledge. Now before we get started working through what was deemed to be difficult probability GCSE maths questions, let's just have a quick overview over what it is that we actually need to focus on. Now with probability, it is vital that you read the question and you understand the situation. I cannot emphasize that enough. Now though the basic formula of probability applies, where it's the number of times an event can happen over the total number of times, the totals may change depending on whether it's classed as being conditional probability or just regular independent probability. And there also may be different combinations or ways in which the required event can happen. Now often there is no indication that a diagram may be useful or is recommended, so you need to have like Venn diagrams, tree diagrams, sample space diagrams in the forefront of your mind when answering these types of questions. Now also what makes this topic difficult is that no question is the same as another. So regardless of how many questions you practice or questions you find challenging but then find the answers to, there is a good chance that that question will never really ever be written again for you to do the same sort of thinking towards it. But what you might find is that with practice you will get familiar with what you can and can't do with probability, and also get used to the vocabulary and the structure of how these questions are written. So let's get straight into the questions on this topic test. Now a little reminder, if you want an access to these questions, all you need to do is just simply click on the link in the description below. So looking at question 1, it says there are 14 colouring pencils in a box. 5 of the colouring pencils are red. Ariel randomly picks a colouring pencil and then replaces it before picking another. Work out the probability that the 2 colouring pencils are not both red. So for this, what she is doing, she is picking a pencil, looking at it, putting it back in the pencil case and picking another one. And the question is asking what's the probability of them not being red. So of them not both being red is the key thing to look out for. So in terms of there's a couple of ways in which we could answer this question. So in terms of what it is that we want, so with probability at least both not red, when 2 are chosen. So that's going to be either the probability of getting a red and not red, or probability of not red and red, or the probability of not red and not red. So if I then work out each of these little individual probabilities, now if 5 pencil crayons are red, then out of 14 that means that 9 are going to be non-red. So the probability of getting a red and a non-red, well that's going to be the probability of red is 5 over 14, and then you put that pencil back, and then how many non-reds are there? Well that's going to be 9 over 14. Then all means plus, so then looking at the second possible combination we could have, so not red is 9 over 14, and the probability of getting the next one being red is going to be 5 over 14, and then plus, because we've got another or, then the probability of not red is 9 over 14, and the probability of the second one not being red is 9 over 14 as well. Now if I then work out each of these probabilities, so for this one I'm going to get 45 over 196, this one's going to be exactly the same, and this one's going to be 81 over 196, and that gives me an answer of 171 over 196. Now another way you could answer this particular question, which will probably be a little bit quicker, don't know what's happened there, and another way of dealing with this question is to basically do 1 minus the situation that you don't want, which is I don't want both of them being red. So then this is going to be 1 minus the probability of it being red is going to be 5 over 14. Probability of the next one being red is 5 over 14. And if I type that all into my calculator, I get 171 over 196, which is the exact same answer. But it all depends on how you're thinking of these questions. But ultimately, If it's correct and you show your full working, you should still get the same answer. Moving on to question 2, it says that a box of 30 building blocks contains red and blue blocks. 17 blocks are red, 13 blocks are blue, 2 blocks are taken out at random without replacement. Work out the probability that the 2 blocks are the same colour. Now, without replacement basically means when a brick is selected, it's not put back in. So this means that the totals will be changing. So if we're wanting the box to be the same colour, then ultimately what we're wanting is the probability that they're both red, or the probability that they're both blue. Now, looking at the probability of they're both being red, well, if there's 17 to begin with, 17 out of 30, then in my second pick, I'm only going to have 29 blocks. And out of those 29 blocks, I've already taken 1 red, so that means there's going to be 16 left. All means plus. Then the probability of it being blue, well, how many blue ones are there? Well, they're 13. Oh, I've got them the wrong way. 13. And there are 30 blocks to choose from. Then if I've selected a blue one, that means there are 12 left, and there's also going to be 29 to choose from. So if I type that all into my calculator, I'm going to get 136 over 435 plus 26 over 145, because that's been simplified. And if I type that all into my calculator, I'm going to get an answer of 214 over 435. So then moving on to question 3, it says in a bag there are yellow, green and pink counters. There are 5 times as many yellow counters as there are green counters. The number of yellow counters to the number of pink counters is in the ratio of 7 to 3. 1 counter is chosen at random. Work out probability that the counter is either yellow or pink. Now with this, we've got a combination of some algebraic expressions and a ratio. So let's first of all start by writing down the ratio. So here we've got yellow, we've got green, and we've got pink. Now, taking this statement here, it says that there are 5 times as many yellow counters as green counters. So if the green counter was x, then the yellow counter will therefore be 5x. Then looking at the next statement, it says the number of yellow counters to pink counters is in the ratio of 7 to 3. So this is 7 and this is going to be 3. Now, when it comes to ratios, they're always talking about parts. So looking at the yellow, that's the one that's being used twice in both those two conditions. So what I then know is that 5x equals 7 parts. Now, because I want to work with G, I want to find how many parts G has got. Well, if 5x equals 7 parts, then 1x is going to be 7 over 5 parts. So I can write, let's just use a different colour, so I can write this as 7 over 5 parts. Now, looking at the number of parts, if I then decide to write that as a ratio, so then what that then becomes is 7, and 7 over 5 as a decimal is 1.4, and then that's to 3. Then if I multiply everything by 5, so that everything becomes a whole number. So 7 times 5 is 35, 1.4 times 5 is 7, and 3 times 5 is 15. I've then got whole numbers as a ratio. So from this, what I can then do is now work out the probability, because I'm now dealing with parts. So in total, what I've got is I've got a total of 35 plus 7, which is 42. 42 plus 15 is 49 parts. And let me just double check to make sure that that is correct. 57 parts rather. So the probability of yellow or pink, well, the number of parts of yellow is 35, the number of pink is 15, and that's all over a total number of parts of 57. So 35 plus 15 gives me an answer of 50. So it's 50 over 57, and there is my final answer. Then moving on to question 4, it says that a pencil case contains 20 pens, 12 are black, 5 are red and 3 are purple. Yasmin takes a pen at random before putting it back in the pencil case. Dante then takes a pen at random before putting it back in the pencil case. Anya then takes a pen at random before putting it back in the pencil case. Work out the probability that they all take a black pen. Now, so this one is the total, because they're putting it back means the totals are not changing. So let me try and not write highlighter. So with them putting it back, totals are not changing. So the probability that Yasmin picks a black pen is going to be 12 out of 20. And the probability that Dante picks a black pen is again going to be 12 over 20. And the probability that Anya picks a black pen is going to be 12 over 20. So then all I need to then do is simplify. Well, if it was a non-calculator, I probably would simplify this. So that would be 6 over 10. So it would be 3 over 5. So that equals 3 over 5 times 3 over 5 times 3 over 5. 3 times 3 times 3 is 27. And 5 times 5 times 5 is 125. So there is my final answer using non-calculator method. Then for 14b, it says all 20 pens are in the pencil case. Aidan takes 3 pens at random, one after the other. After they take a pen, they do not put it back in the pencil case. In other words, here the totals are changing. Now Aidan's first pen is red, so we know that a red pen has been taken. Work out the probability that all 3 pens are going to be different colour. Well, if we know that a red pen is taken, then that means that after the first pick, we have 19 pens, and of those 19 pens, 12 are still black. We have 4 red, because 1 red has been taken, and we have 3 purple. Now the question is asking, work out the probability that all 3 pens are going to be different. Well, he's already picked a red pen, so the probability of all 3 being different is going to be either picking a black one and then a purple one, or a purple one and then a black pen, because he's already picked a red one. So working out probabilities of this, the probability that it's going to be black is 12 over 19, and then the probability of the next one being purple, well, all the purples are still there, but there's 18 pens in the pencil case. Then all means add. Now the probability of the first one is being picked, so that's going to be 3 out of 19. Then we've only got 18 left, so the probability of it being black is going to be 12. So then if I simply type all of this into my calculator, I get an answer of 4 over 19. Then moving on to question 5. Well, actually, let me go back. Now, if this was a non-calculator paper on a non-calculator, then all you'd need to do is basically just simplify the fractions. So I can simplify both 12 and 18 by dividing both by 6, so that becomes a 2. That becomes a what we divided that one by? Divided that one by 6. That's going to be a 3, and this is going to be a 1. That's going to be a 6, and then you can then simplify the top and the bottom. So that's therefore going to be equal 1. So that's going to be 2 over 19 plus, and then here we're going to get 1 over 19 times 2, which then becomes 2 over 19, which then becomes 4 over 19, which is the same as what we've got there. So always be mindful that these types of questions could appear on a calculator and a non-calculator paper. Now going back to question 5, it says visitors at a theme park buy a child ticket and or a adult ticket. Here is some information about the two groups of visitors. Group A has 120 visitors, of which 50 are children, and Group B, the number of children to the number of adults is in the ratio of 17 to 13. One visitor is picked from each group at random. Is the statement correct? The probability of picking 2 children is less than the probability of picking 2 adults. So let's have a look at this. So looking at this first statement, what we want to do is we want to work out the probabilities of selecting a child and an adult from each of those groups. So looking at Group A, we know that there are 120 visitors and 50 of them are children. So looking from this, the probability of selecting an adult, well, the number of adults is 50 take away from 120, which is going to be 70. So it's going to be 70 over 120, and the probability of picking a child is 50 over 120. Now I'm going to leave it unsimplified, but again, if you wanted to, you could easily simplify just taking the 0 out, and we've got a much smaller fraction to deal with. Then moving on to B, the probability of selecting an adult from Group B, well, here we've just got to look at the number of parts. So adults are 13 parts out of a total of 30 parts, and the probability of selecting a child is 17 parts over a total of 30 parts. So then going on to this question, what we want to do is we want to pick the probability of selecting 2 children, so picking a child from Group 1 and a child from Group 2. So probability of selecting a child in Group 1 is 5 over 12, and the probability of selecting a child from Group B is going to be 17 over 30. Now if I type that into my calculator, I get an answer of 17 over 72, which as a decimal is 0.2361 recurring. Then if I then work out the probability of selecting 2 adults, so an adult from Group 1, an adult from Group B, so the adult from A is 70 over 12, or 7 over 12, multiplied by the adult in Group B, which is 13 over 30, equals, oh, don't know what's happened there, equals, and if I work that out, I get an answer of 91 over 360, and as a decimal, 0.2527 recurring. So all that's left for me to do is to compare this statement and also to check whether this is true. So is the probability of picking a child smaller than picking 2 adults? And as you can see, yes. So the answer is yes, as 0.2361 recurring is less than 0.2527. Then moving on to question 6, it says that a bag contains 16 discs, 7 are green, 9 are yellow, 2 discs are taken from the bag without replacement. So again, without replacement means totals change. And it says write down the probability that at least 5 green discs are still in the bag. Well, in order for there to be at least 5 green bags, there's a couple of options we could choose. So either, well, the worst case scenario is that 2 green discs are taken. So if 2 green discs are taken, we're still going to have 5 left. So basically, you're guaranteed when you're picking 2 discs to always have at least 5 green discs in there. So therefore, the probability is going to be 1, or you could write 100%. Then it says work out probability that there are at least 6 green discs left in the bag. Well, in order for there to be at least 6 green, then either you're picking a yellow one and a green one, or the probability of a green and yellow, or the probability that you're picking 2 yellows. So the probability of this happening is going to be 9 over 16 multiplied by 7 over 15, or means add the probability of green and yellow is going to be 7 over 16 times 9 over 15, and then the probability of 2 yellows is going to be 9 over 16 times 8 over 15. And if I plug that straight into my calculator, I'm going to get 63 over 240 plus 63 over 240 plus 72 over 240. Add the numerators together and I get 198 over 240. and that should simplify, and it does simplify to give me 33 over 40. Then moving on to question 7, it says that a bag contains 25 balls, 15 are green, 10 are yellow. One ball is taken at random and replaced by 2 colours of the other colour rather. Another ball is then taken at random and then replaced by 2 of the other colour. Another ball is taken at random. Work out the probability that all 3 balls are taken are green. So let's have a look at this. So we want to work out the probability of green and green and green. Now to start off with, the probability of selecting a green is 15 out of 25. Now if we select a green ball, that means there's going to be 20 balls left, but then you're going to put 2 more yellow ones in there. So total we're going to have 26, because 25 take away 1 plus 2 is 26. Now we're also going to have 1 less green one, so that means it's going to be 14 out of 26. Then in the third pick, we're going to have 13. There's going to be 13 green ones because you've selected 1, and there is also going to be 26, take away 1 plus 2, 27 balls to choose from. So then if I type all of this into my calculator, I get an answer of 2730 over 17550, which does simplify to give me 7 over 45. Then moving on to question 8, it says that a bag contains 15 balls. Balls are green or yellow. A ball is taken at random and not replaced. A second ball is then taken at random. The probability at least one of the balls is green is 23 over 35. And the question is asking how many of the 15 balls are yellow. So in terms of what we've got here, now this yellow statement basically means that 1 minus the probability of them both being yellow is 23 over 35. So that means then, now if you want to work out the probability of it being yellow, well that's going to be 1 minus, now the probability of the first one being yellow, and again we don't know how many yellow ones there are, so we'll just call that y, but we do know that there's 15 balls altogether. Now if you multiply that now, if 1 yellow ball has been taken, the number of yellow balls left is going to be y minus 1, and the number of balls left in the bag is therefore going to be 14, and that equals 23 over 35. Then if I get rid of the minus 1, take away from 1, so what I end up with, I just need a bit of space, I've got 1 minus 23 over 35 equals, and it's going to be y over 15 times y minus 1 over 14. Now if I simplify this, I get an answer of 12 over 35, and if I look at the algebraic fractions and multiplying, I get y minus 1 all over, and it's 210. Then if I do a bit of cross multiplying, which I'm massively running out of space, I end up with 35y minus 1 equals, and it's going to be 12 times 210, which is 2520. It then becomes a quadratic equation, so here I've got 35y squared minus 35y minus 2520 equals 0. Then if I then solve this quadratic either by factorising or by using the quadratic formula, I end up with y equals 9 or minus 8. Now y can't equal a negative number, so the correct answer is that y must equal 9. Now that seems like a very long-winded way of getting the 3 marks, but I'm sure there is probably a quicker way of doing it, but I'm hoping that this method makes a little bit more sense to you. Then moving on to question 9, it says that a bag contains some counters. There are 8 red counters and X blue counters. The counter is taken at random and not replaced, and the second counter is taken at random. The probability that both counters are blue is 1 over 5. Show that x squared minus 5x minus 14 equals 0. So this one is what we call probability equation. So it says that a bag contains some counters, 8 are red and X are blue counters. So that means that the total number of counters is going to be 8 plus X. Now it says that a counter is taken at bag and not replaced, and the second counter is taken at random. The probability that both counters are blue, so the probability of picking a blue and a blue, so the probability of selecting a blue is going to be X over 8 plus X, and, which means multiply, the probability of the second one being blue is going to be X minus 1, and then how many counters are going to be left? Well, it's going to be X, 8 plus X, take away 1. Now if I simplify that, I get X over X plus 8 times X minus 1, and 8 take away 1 is 7, so that's going to be X plus 7. And that is equal to 1/5. So then if I take this and just move it over here so we've got a bit more space, I can do a bit of multiplying. So X minus 1 over X plus 8, X plus 7 equals 1/5. Now if I do a bit of cross multiplying, I get 5x x minus 1 equals 1 x plus 8 x plus 7. Then expanding the brackets out, I get 5x squared minus 5x equals x squared plus 15x plus 56. And then if I take everything all onto one side, this side here, I'm going to end up with 4x squared minus 20x minus 56 equals 0, and then divide everything by 4, in which then I get x squared minus 5x minus 14 equals 0, which is what they wanted me to show. Then moving on to question 9b, it says work out the values of blue x. So all we need to do here is solve this equation. So if I solve by factorising, I have x plus 2 x minus 7 equals 0. So then x equals minus 2 or 7. Now it can't be negative, so x cannot be negative. So x must equal 7, and there is my final answer. Then moving on to 9c, it says work out the probability that both counters are red. So that's just simply going to be 8 over 15 multiplied by this 14 left over picked to a red one, and there's going to be 7 red left, and that equals 56 over 210, which then equals 4 over 15, and there is my final answer. Now I might be thinking to yourself, well, how can that be the same number of marks as B and C? Well, simply because we've done all the legwork, and then C is using those answers, and if we've got those answers correct, then we'll get 9C correct as well. So that's why the marks are, I would say, quite disproportionate in terms of the work that is involved.